Stuck on CNA labs? Tired of scattered tutorials? This full course covers every exam topic with real lab configs. Grab your free lab in the description. Ready to pass CNA and boost your career? Start now.
Hello, in this lesson, we'll learn about the hardware components of network devices and some of their functions. After completing this chapter, you should be able to understand the hardware components of our network devices and the functions of each component. Second, you need to understand how we manage these network devices. Third, understand some basic knowledge about cabinets. Let's start with the first part. Components of network devices. A network device is actually quite similar to an ordinary home computer. The functions it has, it basically has. The components are pretty much the same. What's closest to us users are the various interfaces we can see. Various interfaces. So what's connected internally to these interfaces? Like our memory. Right? Memory. And memory is further divided into ROM and RAM. ROM is our read-only memory. Read-only memory. It stores some programs like the post process and some mini iOS. This is some small rescue programs used when your operating system is lost, along with some boot programs, etc. And what about RAM? This is the memory found in ordinary computers. When your device powers on, it needs to read some things from our storage. This flash from our hard drive to read some things. So where does what it reads go? It goes into our RAM. Right? Stored in memory, including the various processes we will start later. They also run in memory. Then another one is called NV. Compared to RAM, it is a non-volatile memory. Non-volatile memory. This part has very small storage space. It is mainly used to store our configuration files. Our network devices. You need to make some configuration. These configured contents are placed in this configuration file. So these contents are stored in NVRAM. Another is called flash. Flash is like the hard drive in your computer. The contents stored on the hard drive are much more. For example, our operating system, the iOS, also some database files, like the VLAN database. It is also stored in this flash, including other contents, all stored in this flash. This is a place for storing. As for the configuration file, it is a separate. Of course, not all. On some devices, RAM and flash are merged. Both are placed in flash. Then next is our CPU bus. That is our CPU. Right? It processes all kinds of data. Okay. So here, each part has its own functions. Like the CPU, its main role is to execute the various instructions of our to compute all sorts of things. Right. And then, our memory, what it is. Our brain. Then RAM. This we call memory. This part of memory, it is the contents stored inside. After a power loss, they will be erased. Just gone. This is why when we boot up, we need to read some operating system. Read some files. Right. So when reading, where to put them? Put them into this Then when you shut down, this content is gone. Next time you power, read from flash again. That's it. This is called RAM. Called memory. The ROM, then, mainly stores the bootstrap program, the bootloader, and also some mini iOS. This is mainly for rescue purposes, or for when you forget your password. And NVRAM, as just mentioned, mainly stores some configuration files. Flash, well, is for storing our operating system. Interfaces are for connecting our various cables and communicating with the peer device. Okay. So this device after being powered on, how does it become operational? So these are its startup steps. Right? First step. After powering on, all computers, including our network devices, are the same. They all perform a hardware check. They all run a hardware self-test. Like our computers. If there's a hardware, right? If there's a buzzer, it will make beeping sounds. That's performing the self-test. If the self-test passes, it starts loading the bootstrap program. To locate the operating system, it starts looking for the OS. Then step 2. Find the iOS. That is, the operating system software. This operating can be stored in right? First, locate this iOS. Which is the operating. It might be in the internal storage. That is, called Flash. Right? Alternatively, over the network. Downloaded via TFTP from a server. That's also possible. It's possible. But this method is rarely used. It's almost always in the flash memory. In its flash memory, we place the operating system there. Then it finds the operating system and starts loading it into memory. Loaded into memory. Then it starts run, right? After the system starts up, it looks for our configuration file. If the device is brand new, with no configuration at all, at this point, it enters a blank configuration startup, which is the factory default state. It loads this default state. If the device has been configured by us, it will first go to your NVR to find your configure. If it's not found there, could it be on a TFTP server? On the network, on other servers. If it's available, it downloads it from the TFTP server. If not, you configure it directly from the console. Right? So these are its basic 3 startup steps. First, pose. Then, if no issues, it boots. It loads our iOS. It starts looking. It finds the iOS and loads it into. After loading into, it starts looking for our configuration file. It finds the config, and then the startup is complete. This process is fairly simple. Right? Cisco devices and devices from other vendors are all the same. Right? They all have their own operating system. Cisco's name for is iOS. It's called iOS. It's a customized, small operating system developed specifically for its hardware. A small operating system. Different devices. Its version is also different. The content is different too. So you need to find the right version for that specific device model and its corresponding operating system, iOS. This you can download directly from Cisco's website. Download directly. Of course, when it comes with it by if you accidentally, right? Say, if you format its flash, then you might lose it. After losing it, you can download it from Cisco's website. If you can't download, you can ask the right? The instructor will okay. Now, as for this iOS, you need to configure it. You can't just use these devices out of the box. Right? For enterprise level, we always need to configure and adjust it. Otherwise, if no configuration, network engineers, right? A primary role of a network engineer is to configure our network devices. Configure network devices. So how do we configure this network device? We have several methods. The first is through the console. Through the console, that is, through what we call the console port. Through the console port, to configure our device. This method we call out-of-band management. Call out-of-band. What is out-of-band management? It has nothing to do with our service cables. It has nothing to do with service cables. It's directly external management. Whatever services are running inside, none of that is needed. You go directly through the console port. Every enterprise-grade manageable device will come with a console port. If this device, you can't find its then most likely this device is an unmanaged device. These are commonly called dumb devices. Many home-grade devices don't have a console port. But these devices are relatively cheaper. Our enterprise-grade devices generally come with a console port. They require a network engineer. Right? Using a specialized, called a console cable. Plug it into the port, and then use the corresponding terminal software to manage it via command line. This is called console, which is out-of-band management. Then there is another, called telnet or SSH. Using these two remote management protocols over our service line, meaning the network cable plugged in here. Right? This might connect to a switch, and then to other devices. Right? Then your computer is connected here. And over the service line, you remotely access this device for configuration. Generally, this is used when the device already has network management already configured. During later maintenance, we'll use, generally speaking, for a brand new device or one restored to factory settings, we need to use the console. to manage it. Of course, there are more advanced management methods. Using a controller. Using a controller to automatically onboard these devices. And automatically, that is more advanced. This will be covered later in the CCNP, where we will explain it. Now, Telnet and SSH both use this in-band management method. We call this in-band management. This band refers to the network bandwidth, right? It refers to our network cable. It refers to our network cable. You manage the device through this cable using these two protocols. Generally speaking, we recommend using because SSH is encrypted. During the entire, all the commands you type, all the configuration, and all the status are fully encrypted. Telnet, on the other hand, is plain text. If this content is captured, everything the attack is exactly what you see. So its security is somewhat weaker. Besides these two methods, there is another port. This thing is not available on all devices, but on devices like Cisco. Some models do, basically, they all, but for devices from other vendors, they might not include. This is called an AUX. We also call it an AUX port. AUX port. The one above is the one below is the AUX port. The purpose of this is for when your console port fails. For example, if this device has been running for right, and the operating environment is quite harsh, this port might be broken. No response after plugging it in, right? At this point, you can try using it serves as a backup interface for the console port. So, it's called an auxiliary port, right? Called an auxiliary, it is used when your console port fails. Use the port below, and you can still manage the device. As for the other methods, they are basically through. The most common way for us is through remote methods like Telnet or SSH to perform manage. Okay. So, that's one method for managing devices. There are two methods. One is out of band, the other is in band. If you want to use out of band to manage these devices, we need a specialized cable to make the connection. This cable is called a console cable. One end of this console cable has an RJ45 connector. It's a standard RJ45 connector. And the other end? This is called a serial interface. This is a DB9. It has 9 pins inside. It has 9 pins inside. Then, so what is this? On old desktop computers, the motherboard often included this DB9 port. Such a connector. You simply plugged in the console cable. It just worked. Right? But modern computers are getting more and more, right? Legacy interfaces like this are generally gone, they are obsolete. Right? So at this point, we need a USB to DB9 cable. Connect both ends, then plug the USB side in and you're set. Now, some even lack USB-A ports. Right? No USB-A. In that case, you might need to find a Type-C. A USB Type-C connector. Right? With DB9 on the other end. Of course, this is quite rare. Generally quite rare. What is more common? Like the one on the right, it is integrated directly. Integrated together. This end is the console connector. Right? The RJ40, and this end is. And this end is our USB port. It is a Type-A connector here. Our standard, large USB port. So if your laptop or computer lacks this USB-A port, you can simply use a docking stick, right? To add a Type-A interface. Or alternatively, just buy the Type-C one. Just buy the Type-C one. When buying it. As a network engine, right? This console cable is definitely essential. So when you buy it, pay attention to your console cable. Buy it a bit longer. Buy it a bit longer. At least 3 meters minimum. 5 meters is better. Right? 10 meters is better. That's even better. Right? Why is that? Because inside the server room, the device you need to manage might be on the very top. Right? It might be on the very, and then you have nowhere to, you can only sit cross-legged on the floor. So the distance is at least 2 meters then. At least over 2 meters away. Right? You can only sit in, if your cable is a bit longer. You can adjust to a slightly more comfortable position. Right? Because configuring one piece of equipment, this device might take a long time to set up. Right? Might take a long time. A longer cable gives you a bit more freedom. Of course, these all use wired connections. Wired connections. Nowadays, there are other management methods. Console cables. Use Bluetooth. It has a Bluetooth adapter. And on this end is a console port. And on the head, this is our standard RJ45 connector head. The top is just a regular RJ45 connector. Then you plug one end into our console port. Then turn on Bluetooth on your computer. Most of our laptops now have Bluetooth. Right? Pair it via Bluetooth, then manage our device through Bluetooth. So there's no cable in between. No cable at all, right? As for the distance, generally speaking, 20 meters is, right? It even works through, so you can find a more comfortable spot. You can even grab a small stool. Or go configure it from the next office. That works too, right? This is quite a bit, but this Bluetooth gadget, compared to our wired method, first of all, its anti-interference capability isn't as good. If your server room has some devices with stronger interference, then the Bluetooth connection might be quite laggy. Or it might even fail to connect at all. Right? Secondly, this thing is a bit pricey. They generally start at over 100 yuan. Right? Some might be even, you'll find many and a third reason. Another reason it's not that great to use is that while it's handy, it's easy to lose. Easy to lose. Like, you finish configuring. You're done configuring it. Then you test the server. You're pretty happy, you pack up your laptop, and then you leave. Then you leave your console cable in the server room. Right? Left in the server, it's easily lost. Easily lost. Then someone sees it, right? You go back and this stuff is right? Everyone likes it. They see it and might, these types of cable, you should keep your own. Buy your own. As a network engineer, this cable is without this thing, you can't be a network, right? Okay. Now, currently, like the first type, this separated is also available. This one is why? Because this thing, once it has a right? For example, the front, 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 right? For example, the DB9 to R, if this cable breaks, spares are easy to find in many places. Right? And also this back part is also easy to find, but if it's the all-in-one type, all-in-one, well, this one has a fixed length. The length is fixed. So, sometimes, if you need to reach far, it's not very right? So I suggest using a split type one. The length can be much longer. It can typically reach 5 meters or more. As for Bluetooth, get one if possible. If not, well, carry the left one. And also carry the middle one. Right? Carry at least 2 cables. Carry at least 2 cables. As network engineers, sometimes when doing cutovers, during a project, it might be in the early morning. During the day, business traffic is running, right? There's traffic flowing. Only during these early morning hours are you allowed to do network cutovers. Network operations, right? So you go to the server room at midnight. Start configuring, and halfway through you find the console cable is faulty. That's frustrating. Buying one online won't arrive in time. And there's nowhere to buy one offline. Right? I've basically never seen these cables sold in physical stores. So what can you do? You can only ask your colleague or friend to bring one to you. Right? Have them so, I advise network engineers to carry at least 2 console cables in your bag. Experienced network engineers always have at least 2 console cables in their bag. Just in case. If a problem occurs, I have another one as a backup. Remember, redundancy for network engineers. The concept of redundancy when problems occur is very thorough. Everything considers a backup plan. So, when using it, it is like this. One side, right, connects to our computer's USB port, or a USB Type-C port. Plug it directly into your computer, or via a docking station, then plugging into your USB port works the same way. Anyway, just connect it. Then the other end plugs into the console port. As for whether the middle part is a single piece or segmented, it doesn't matter, or even a Bluetooth one is. Bluetooth simply means this side connects via Bluetooth, right? Then through terminal configuration software, There are many terminals. The mainstream ones we use most often are Secure CRT, also PuTTY, and also Shell, and also Mobisterm, and so on. There are a bunch of them. If time permits, regarding these softwares, I will give a separate lecture later. You open these softwares, adjust the corresponding parameters, and you can connect to our device. Then you can tap away typing commands. You can type commands. Okay, so this is our console cable and how to manage with it. This method is management via our control port. The control port means managing via the console connection. Okay, the third topic is some basic knowledge about our cabinets. As a network engineer, when we are working as a network engineer, what we interact with the most often is either network devices or our cabinets. As for cabinets, well, network cabinets are different from server cabinets. Yes, they are different. What's the difference? First, their depth is different. The depth is different. This is the biggest difference. Because network devices like our switches, firewalls, these devices, their depth is generally 40 to 50 centimeters. 60 centimeters max. It won't reach 60 centimeters. Shorter ones can be just over 10 centimeters. Depth, pay attention to depth. Consider this box, right? This is length. This is height. Right? Then another dimension is its depth. So this is the so-called depth. For depth, generally smaller ones are about 10 or 20 centimeters. Longer ones may only be around 40 centimeters. So the cabinets. Depth, the standard network cabinet. Depth is generally 60 centimeters. The depth is 60 centimeters. That's the distance from front door to back door, 60 centimeters. And then, its height, the overall height of a standard cabinet is 42 U. Yes, 42 U. This is the standard terminology for our cabinets. U stands for unit. 1 unit. One unit is 45 millimeters, which is about 4.4 to 4.5 centimeters. That's 1 U. So 42 U, you can multiply it yourself. It's about 2 meters. Right? It's about 2 meters. Because you also need to add some bottom space. It's not entirely flush with the bottom. Not entirely, there will be some space at the bottom. Leave a few centimeters of space. And on top, there are cooling fans and such. Right, also a few centimeters of space. Including under the cabinet itself. It has support feet or casters. Right, that also takes up some space. So overall, a standard cabinet's total height is around 2 meters. Yeah, around 2 meters. And inside the cabinet, all these outer doors can be removed. Front door, rear door, and both side panels. All of them can be removed. They can all be removed. This frame structure is the middle picture here. The outer part is the cabinet frame. The frame provides support. It plays a supporting role. The most critical parts are these two things in the middle. One is called the mounting rail. Yes, that's the vertical rail. And the other is a horizontal rail. The horizontal rail. The vertical rails are fixed to the horizontal rails. The vertical rails are fixed using nuts and screws. They are secured to the horizontal rails. The horizontal rails are fixed to our cabinet frame. Fixed to the cabinet's frame. They are fixed to the outer part of the cabinet frame. This is also locked tight using nuts. Locked tight. In this way, the whole cabinet has 2 vertical rails on this side. And 2 on each side. 2 in the front, 2 in the, using horizontal rails, also called connecting rods. They are fixed to our cabinet frame. This way, the whole cabinet is secured. Then, we mount our network devices. Note, typically, devices like switches or routers are generally 1 U in height. The height is typically 1 U. Right? So when mounting them, the vertical rails have markings on them. One by this U exactly matches 3 square holes. Exactly matches 3, and here it will mark which U this is. Which U, it will have numbers here to mark for you. For example, this is the 4th U. This is the 4th U, right? Then 3 holes. Then how do we install this device? Note there are these nuts here, right? These nuts are M6. That is, their diameter. The diameter of this screw hole in the middle is 6 millimeters. Yes, 6 mm. Then there is a metal clip on both sides. Metal clips. Then you press the clip on the left side. And then push with your fingernail on the right. To snap the other clip into place. In this way, the whole nut is fixed onto the square hole. Then the second nut is also fixed onto this. Note, fix it onto the lower one here. Not onto the middle one. One on top, one on bottom, leave the middle one empty. Leave the middle one empty. This way, the nuts are secured. Then the right side square slot. On this vertical post. The square hole vertical post is the same. At the same U position. On the upper and lower hole positions. Snap our nuts onto them. Snap them on. I will record a dedicated video for this sometime. To show you all how to install our equipment, alright? For now, I will simply to illustrate it for you. After snapping the nuts on at the same position. Then our switch. On the switch. Generally speaking, our switch. When it leaves the factory. Is just that square box, right? Ah, it does not have fixed mounting ears on the sides. Please, this fixed metal piece we use. This is called a rack ear. It's specifically designed to mount onto our cabinet. Right? So, this rack ear. It is included in the box. Make sure you don't throw it away. It comes with the corresponding screws, right? This ear is then fixed onto the side panel. Fixed on, then using a few screws, typically 4 screws, right? Secure it tightly. Then it will stick out a bit. It sticks out a bit. And that's perfect. Once you slide it in, it catches right on. This spot here. The rack ear catches exactly. There's a screw hole on top. And a screw hole on the bottom. Then, with the screws. Secure it with screws. Just secure it with screws, and that's it. Same thing for the 2 on the right. So, as a network engineer, your arm strength needs to be good. Your arm strength must be relatively decent. Because the slightly heavier 1U switches, their weight is about 10 kilograms. Some are even heavier. But generally speaking, 1U ones aren't too heavy. About a dozen kilograms max, right? So, you need to be able to handle that weight. Hold it with one hand, mind you, one hand. Why? Because the other hand needs to drive screws. Right? So, you have to hold it with one hand. This 1U switch, a 10 kilogram device. Lift it above your head, and then. You must be able to hold it for 5 minutes. You need to meet the standard at least. Well, that's why network engineers are all in good shape. Right? Okay, so after holding it with one hand, you drive the screws in. Once all 4 screws are tight, you can let go. After releasing it, the switch will be firmly secured. Onto our rack post. It won't fall off. It won't fall off. Of course, if a device is relatively heavy. In addition to the front mounting ears, it will also come with rear mounting ears. It will provide these support rails. After connecting them, this prevents your device. Once the front screws are tightened. Right? Then the back end sags due to the weight. Sagging could bend our rack post. Right? Bending it. That would be quite troublesome, right? So, some switches also come with rear mounting ears. This depends on whether your device includes them or not. Not all devices have them. For lighter device, just tightening the 4 front screws is enough. The removal process is, loosen the, then take the device, then the cage nuts. Just remove them. That's it. When installing this device, note that we don't install devices. Say, this is Unit 4, right? And above it is Unit 5. Note that generally, we won't install them right next to each other. We won't install them For example, I install a switch here. And then I install a, that's not how it's done. Because the device generates heat. You must leave space for heat dissipation. Space for cooling. You must leave space for cooling. Right? Generally, you leave one unit empty. You just installed it in Unit, so next you install it in Unit 6. You install it here. Install it, leaving 1 unit of space in between. And regarding the device, its cooling airflow is like, from the front it intakes. Cool air, and then from the back of the machine. Blowing hot air. Generally, that's, of course, if. In some scenarios, the cold air comes in from the back. Then you can. Some switches support adjusting via commands. The forward and reverse rotation of its fans. So you can reverse the airflow. Taking air in and exhausting it from the. This scenario is quite rare. Most draw air in from the front and exhaust out the back. So that's some info on that. In that case, the rack is installed, right? The devices are in, then you place them one by one. And the gaps between the devices. One purpose is for airflow. Another is for measuring heat. Another purpose is for cable routing. For cable routing. Because in the middle, generally, we install our cable managers. Or what we call patch panels. Note that for patch panels in a rack, when connecting cables in a data center, it's not like, this switch port needs to connect to that one. Right? It's not a direct connection like that. There are dedicated patch panels. Dedicated patch, it's actually just like the modules you plug network cables into. Right? The ports on an 86 type wall plate for cables are pretty much the same. It's just much denser. On this patch panel, it has, say, 48 holes. 40, and then your. Above is the patch panel for that 6U device, right? Above is the patch panel for the 6U device. Then you connect this cable to the patch panel. Inside, cables run down from the patch panel to the second patch panel. Then you connect a network cable from the second patch panel. Connect to our 4U device. It doesn't mean directly connecting from here to there. Doing it this way has an advantage. The first advantage is that it looks neat. You won't see a cable hanging down from the front. Right? You will only see it coming down from the 5U. The cable distance will be very short. And the cable management will look much better. Right? The second function is, it is more standardized. When you are tracing cables, the patch panel has corresponding cable labels. It has cable labels. When tracing cables, it's crystal clear. Right? You know which port connects to which port on the other end. You can find it quickly. The third function is, when making these network cables, when dealing with low voltage systems, we call network cables low voltage, right? When the low voltage technician is, there are no high technical skill requirements. Just follow the chart or table you give them. As long as you give them this table, right? Which port needs to connect? Which port needs to connect? Tell them these port numbers. When they are punching down the patch panel, they just punch it down for you. No theoretical knowledge is needed. No messy knowledge is needed at all. So these tasks can be handed over to our low voltage technicians. We engineers don't have to do it ourselves, right? It saves labor costs. Saves labor. That's some basic knowledge about the inside of a cabinet. Now, next, as you can see, there is a thing called a tray, right? This tray thing. Generally speaking, a tray is used to fix and hold what items? There are two kinds of items. One is equipment that is not standard width. The width of the cabinet itself is fixed. The external width is 60. The outer width is, and the internal width, then. It's about 40-something centimeters. About 44-point-something centimeters. Roughly like this. Then, some devices might be quite small. Maybe about this big, right? For something like this, well, there's no way to just hang it. Mounted on this vertical rack post. Right? In this case, we need a tray. Installing a tray is exactly the same as installing a switch. It's the same method for routing devices. The only difference is our cage nuts go on the side. Pay attention to these rack posts. The posts have square holes not only on the front, but also on the side openings. They have square, so, at the corresponding new position, just snap one in place. Snap in a cage, and then, tighten the screw in. Tighten all four corners. This tray is now secured. Then, and place it on top. It's done. This is one scenario for devices that are not standard width. You can use a tray to support them. There is another case. The device is just too heavy. And it didn't come with rear mounting brackets. It only has the two front brackets. Right? Using screws only on the front post might not hold, it might sag down. Right? In this case, you can use a tray. Secure the four corners, then place the device on top. Done. But this tray, what? You have to buy it separately. And it's, right? They actually cost $20 each. Of course, the client pays for these. We engineers just need to submit, right? So these are things inside a cabinet. Okay. So. And then. Between cabinets. Generally, we place them side by side. Placed closely together. Then, inside a data center, there are some things to note. Some knowledge points that, let me briefly explain them. First is how cables are routed. As for, they are not just tossed around loosely. Right? We have a dedicated thing called a cable tray. The cable, using threaded rods, is fixed to our ceiling, and then hangs down, and then, it's like a grid, a metal rack of that sort, right? A rack with many squares. Then run the cables through it. There is a rack above, there is a cable tray like this above, then they are connected to, this is specifically for running our cables. This is the overhead cable tray. And below, under the cabinet, generally, we install anti-static raised floor. Called anti-static raised floor. It's not about generating, it's about discharge, because inside our server room, it requires constant temperature. Generally, the humidity is quite low. And inside, a lot of electrical devices running, which generate a large amount of so, when entering the server room, many of us engineers will build up, right? Then, when you touch the equipment, it's very likely that static will affect our interfaces. And it might break them down. Or burn them out. This can indeed happen. In a professional server room, the floor is usually covered with anti-static tiles. Through the floor, this static electricity on your body is discharged to the ground. In this way, when you touch the equipment, there won't be this breakdown of our equipment. Right? Or damage to our equipment. This is the floor. And, there are a few other things in the, one is the air conditioner used for heat dissipation. Another one is the UPS. Now, regarding the the AC used in a server room is different from a home AC. It's called a precision air conditioner. Specifically designed for our precision equipment. As for precision air conditioning, well, it can operate 24/7. And also, it can maintain its electrical loss. Its energy efficiency rating is also very high. Basically, it's all tier 1. And then, its airflow methods are divided into two types. One is bottom airflow because the floor below is a raised floor. Right? Yeah, in the data center. Inside a standard data center. For the lower part of the cabinet. The lower part, there is no it uses several support brackets to hold our cabinet up. So underneath, there is no our precision air conditioner blows air downwards. Sending all the cold air to the bottom of our cabinet. And then, the hot air rises upwards. It gradually, right? Yeah. The top is all hot air. Then the air conditioner draws air from the top, sucking the hot air down. After cooling it, using the compressor after the cooling it is discharged into the space under the raised floor. Then the cold air forming a cycle. This cycle can achieve a significant cooling effect. A very good cooling effect. This is downflow. There is another, which is horizontal flow cooling. For horizontal, you usually place the AC unit in the middle. You have a row of you place it it will blow air left and right. Blowing air left and, in this, we need to remove the side panels between the cabinets. Remove all the side panels. And then, air blows from both sides. Then, hot air rises. And it draws air from below. Drawing hot air from above. And then, blows it out from the side. This is precision air conditioning. Some content about air conditioning. Of course, there are other support. Just get a simple understanding here. Another thing is UPS. UPS is actually what? It is a power bank. You know, your mobile phone uses this power bank. We use electrical devices like our network equipment, routers and switches, and also, like servers. These devices, generally, it runs 24/7. No power outages, right? And also, it cannot lose, because we have services running on it. Once the power, especially in financial sectors, like banking and insurance. In these industries, right? In the if the power goes out, it causes our routers and switches to crash, right? A direct shut. After the shutdown, all your data communication stops, right? All your business has to stop. The loss is huge, right? So in many industries, these devices cannot lose power. Regarding power supply, there are two methods. One is mains electricity, the power used in homes, right? This power comes from AC, right? AC power pulled directly from the transformer. Then it's connected to each cabinet circuit. Connected to each pay attention. A standard server when routing electrical, generally it pulls two divided into circuit A and for better equipment. It also has two power supplies. One power supply to prevent if circuit, for example, due to or a short circuit, causing this circuit to be in, right. For instance, a breaker. These are all possible. So that's why we use two circuits. One circuit A goes down, I still have circuit B as support. Right, providing redundant. As mentioned, this concept of in a network engineer's mind must be remembered at all times. Okay, this is regarding mains power. What if both circuit A and B fail? At that point, our UPS, which is our power bank, will come into the power bank is basically a large battery bank containing many and our this we call it an inverter. We call it why do we need to invert? Because AC, we can't store it. We have to store it in a battery. This battery, the battery in an electric vehicle, right? Must be stored in this When storing in the battery, it all uses right? And when you use it, you also use DC power. But our network devices, like servers and such, right? Routers and switches, these things, their power supplies use AC power, right? So, it needs an inverter. It needs and then takes the power from the DC battery, converts it to AC power, and then supplies it to our power unit. Supplies it to This is what happens. The mains power experiences it. The UPS will it will. Of course, the UPS has many other key points. For example, UPS types are divided into standby and online. Right? Standby means when the mains power fails, it will intervene. It will in between, there will be some delay, about 50 to 100 milliseconds. Right? So for some relatively precise equipment, or storage type devices, with many hard drives, not very that is not very friendly. So the more expensive online type means at all time, all your mains power goes through the UPS first, then through feed A and feed B. First through the then through feed A and feed B. Then, the online UPS. At this, will constantly voltage regulation. And also, filter, because sometimes the voltage may fluctuate, right? Also, there can be pulse-like voltage surges, suddenly spiking to, right? That could potentially burn these things out. Right? So the online UPS has dedicated filtering and voltage regulation components right here. All power goes through it for distribution. In this, all our devices get power more stably. More stable. This is about our UPS. This is an online UPS. So, an online UPS is quite for a standby the mains power comes in, right? Passes through it, then goes here. There is no inverting or voltage regulation in between. There is no invert and no voltage regulation component. It just senses. When your mains power fails, it immediately using the battery. Then the UPS inverts. And then supplies your A and B paths with power. Supplies you note about the UPS. This UPS thing, it's not for long-term use. It doesn't mean after a power outage. You can use it for several hours. Generally, it's at the minute, a few minutes, even 1 minute, 2 minutes, like that. This depends on battery capacity. Its main function is to prevent sudden power loss. Prevent sudden if a power outage happens now. And the UPS generally it gives you a 30-minute response window. In our standard day, you might get a 30-minute right if within 30 minutes the mains power hasn't been. At that point, what should you do? Use a diesel generator. Use a diesel, and then connect it. To supply power. So a UPS device is like an insurance. It's a safe. Once mains power fail, it gives you time to react. Gives you time to. It cannot run for a long time. It doesn't support long-term. Because for a single rack. A single, for example, for network, typically it's 10 amps. 10 amp. Some servers, however, might need right. That's a very high power draw. A very high power. This one is 200, correct? This one is over 3000 watts. 3 kilowatt hours per hour. 3 kilowatt. This one uses 1 right? How many kilowatt hours can your battery store? Right? Look at this row here. A whole row of cabinet. Each cabinet drawing 2 or 3. You do them, right? Inside a how many kilowatt hours does it use per minute? Right? You go figure. So, a UPS device. It only gives you a brief response window. A reaction time. It's meant for long-term power supply. It can't handle that. No, it can't. No, okay. So, in this lesson, we mainly covered 3 topics. First, the internal components of our devices. The various internal parts. And also, each of its components and their functions. And when the device power, how does it operate? Right? What does its boot process look like? The second part is how to manage our devices. Via console or through this. Telnet or SSH. Right? These management methods. Also, some tips about server and common knowledge inside them. I gave a brief explanation. Okay, so that's the content of this lesson. That's all.